So my name is Fong-Jones. This is my colleague, Danyel Fisher.
Hello.
And what we want to tell you about is how we have adapted as a company of relatively limited resources to making sure that we have the ability to utilize those resources as fully as possible. So we are operating in a space that has a lot of product requirements that are evolving very quickly. There's a large volume of data we need to analyze. There's an increasing set of demands people have upon their observability tools. And that means that we have to balance things like reliability and velocity and not compromise on any one of them. So we're a team of a dozen engineers. This is 1/6 of the Honeycomb engineering team standing up on stage right now.
Which means our velocity has dramatically dropped for this occasion.
Although Danyel and I write a little bit less code than the other engineers. So what's the problem space? I feel it's really important to start with context so you can understand what is specific to us and what generalizes to you. So let's talk a little bit about what Honeycomb does. So our goal is to make it so that you can run your systems humanely without waking up a bunch in the middle of the night, without tearing out your hair trying to figure out what's going wrong. And in order to do that, we need to ingest telemetry. We need to ingest telemetry from your systems, and a lot of it, and enable you to ask ad hoc queries, not pre-aggregated queries, but any query you might think of, and make it run performantly enough so that you can really feel empowered as an engineer to understand what's happening inside of your systems. This is not an easy problem. And yes, we deploy on Fridays and every single other weekday, but not on the weekends. So let's talk about how that works. So this is what the number of distinct build IDs running in our systems is per day over the past year almost. And what you can see is that we ship anywhere between 10 and 16 times per day on an average weekday. And obviously there are periods like the December holidays where we don't really ship. We try not to ship on weekends. We're successful most of the time, as the graph shows you. So that is what high agility looks like for our 12-person organization. We're not a 10,000 engineer organization, right? We're not shipping things hundreds or thousands of times per day because we literally don't have that much work to ship, right? But we are finding that we've developed the necessary investment in our continuous delivery systems so that our continuous delivery system is not the thing slowing us down or preventing us from shipping. The thing that's preventing us from shipping is our engineering bandwidth as individuals. And that is a really great place to be in. But it doesn't happen magically. It doesn't happen overnight. So let's talk about what it took us to get there. So what it took us to get there was a roadmap of what did we want to do and how are we going to do it. We needed to really invest in the right set of tooling for us. And that doesn't mean adopting everything and everything under the sun, right? We don't need the entire alphabet soup in order to be productive. In fact, that would be counterproductive. It would really slow us down if every engineer needed to think about, OK, how do I make the Kubernetes work? How do I make the PagerDuty work? How do I make X and Y and Z work? So it means that we had to make really thoughtful choices, both about what vendor products do we adopt, what open source products do we adopt, and also what things do we maybe reuse between projects, and what do we develop greenfield from scratch. And hint, we actually did not develop that many greenfield things from scratch, and the ones that we did were relatively simple. So let's go ahead and talk through some of that. Oh no, did the pager die?
I have done something terrible to your clicker.
Let me see if I can fix it. Oh, I think I understand what's happened. Let's try doing, that's never happened before. OK, that's better.
Sorry about that.
In the event it breaks again, we can just click on one of the previous or next slides. OK, so we needed technology, but really we also needed the right cultural processes. That we needed an engineering culture that valued continuing to maintain high agility. And that we needed a culture that valued balancing reliability and agility and making sure that we could hit the sweet spot between them. It also meant that we needed to kind of continuously improve, that we couldn't say our systems are good enough. We needed to always be looking at what's slowing us down from shipping, and when it got big enough, to actually invest in fixing it. And really improve the things that matter and not spend time chrome polishing on things that don't actually matter. So our goal really is to do 4 things. we're aiming to tell you 4 things today about how we got here. First of all, how we ship product quickly at Honeycomb. Secondly, how we shipped things safely on reliable infrastructure. Thirdly, how we embrace risk and use it as a signal, as a feedback signal to build our product better. And finally, how we never stop improving, how there's always a list of things that we think are going to make it better at the right time. So, Danyel, you're a little bit closer to the product side than the infrastructure side, which is what I work on. So why don't you tell us about how you experience Honeycomb's delivery process?
Sure. And I'm going to start off by saying I come from a largely academic background. I was a number of years at Microsoft Research doing data visualization and analytics before I joined Honeycomb. So a lot of this experience with DevOps has been completely new to me, which means as I'm telling this story, there's some things that seem routine because they're now my day-to-day life at Honeycomb, or conversely that seem really surprising to me because they're totally unlike my previous life. That said, this morning, Nicole Foskren was talking about the idea that CI/CD is sort of like the best drug dealing. And what I think I want to do is give you the story of what it's like to be riding that high. So I'd like to talk a little bit about sort of the how a bill becomes a law of Honeycomb. You know, what's our recipe for making stuff happen? One thing that stands out to me is that from the very beginning, every line of code that we write, we tend to instrument as we're going along. So I'm thinking about, as I write my pieces of code, what the business logic's going to be, what the ways that this can possibly fail, and what messages I might want to emit to the user.
And this doesn't mean that we overwhelm things with logs, right? Instead, our goal is to produce wide events, to produce data that is comprised of key value pairs associated with everything that flows through our system, so that we can easily correlate those key value pairs and understand post facto what happened and why inside our system.
So, for example, recently we were working on a new feature that entailed a complexity of like how our caching systems spoke to inputting user data and new data and old data. And we realized there was a lot of complexity. And we ended up spitting out a whole series of wide events as we were doing this that gave a snapshot of what our cache was doing and how it did it, which really allowed us to very quickly narrow down on what was going on as it happened. On the way, we're also, of course, doing test-driven development. Not only are we doing functional testing, though, but we've also taken on a practice of doing visual testing, at least if you're on the UI side, like I am. We've been using a tool called Storybook and using Storybook's automated testing. So now when anybody changes anything in React, because React has this weird habit of like you tweak one thing over there and a whole bunch of other stuff on your UI changes over there. Whenever someone does that in our React world, the Storybook tests start failing, so we can very quickly see what's gone on, and also we can actually pull it up visually and look at it and see whether it looks the same or different to us, which is a nice touch over traditional snapshot tests. It makes upgrading libraries also a whole lot less scary. We do most of our code wrapped in feature flags. So in fact, most new features that show up appear as no-ops to our users. We can put them out and on our dog food system, test them internally, and then once we're beginning to feel comfortable, start rolling them out either to users who have opted in or eventually to the world.
It's the same code, right? It's the same code that's running in dog food and production, just with a different set of feature flags applied. So this is not kind of this notion of different staging environments, right? Instead, it's using feature flags to manage the blast radius of our change effects.
Right. But yes, I think it's absolutely critical to say there's only one version of our code that's running at any given time. This sits on top of an automated integration process. We use CircleCI to manage it. Here's our CircleCI view, and you can see that, like, you know, we actually have done a bunch of the stuff that they were talking about this morning. And yesterday, Steve Pereiras was talking about the value stream concept. So it was really nice to be able to see like the flow of where our data was going and how long it takes each step to work out. But it doesn't really give you a good signal on where are your bottlenecks, right? Like what's slowing you down. So we have a different view as well that we designed in-house. Right. So this is using the Honeycomb trace view, where we've actually instrumented each step of the build process as a CircleCI orb so that we're able to have it automatically emit this trace. So now I can look at this at a glance and see, for example, that the Go tests are certainly not a bottleneck. They're only taking, 114 seconds, while the JavaScript dependencies, this one chunk called poodle yarn, is taking, almost 300 seconds, which begins to tell us where we want to look and how we can parallelize this process further. We'll see in a few slides how we've actually used that process to keep improving our builds and help make that work faster. So using automated integration, we can always feel and testing, we can always feel pretty sure that our builds are successful, that the thing that we're going to merge isn't going to cause things too much on fire. That said, humans are good. We, of course, practice human PR review. In fact, every single PR is reviewed. 2 days ago, I approved a PR from someone else that was literally remove unused comment. It was safe. I am absolutely positive that the senior engineer who put that PR together could have glanced at it and said, yup, it's fine. But the really nice thing about just having the company standard that if it's a PR, some other human has looked at it, it's fine, means that there's never debate about whether it was significant enough, whether this was a change that should have been approved. Of course it was a change that was approved because everything was approved.
P.S. This also makes your SOX auditors a lot happier with you.
And as Heidi Waterhouse was talking about this morning, the importance of very small changes means that we're able to also get very highly reviewable PRs, which means that our PR turnover process is super quick. I know a couple of people who enjoy waking up in the morning and drinking their coffee and reviewing a handful of the easier PRs as they start their mornings. I think it was unfair we count so much on CircleCI. We should also give the robot a high five here. As Liz was saying earlier, we practice green button merges. So once we feel good about that, we can merge that in. The CI system builds our integrated version and starts a deploy going. It's an auto update deploy. Liz will talk a little bit later about how those steps fit together. We use manual rollbacks, but we have a pretty good script that causes that to happen quickly. And we also have the ability to independently pin versions. So sometimes if there's one service that we know is sputtering and another one we need to have gotten a fix out.
Or if we want to do a canary, we can just pin a canary version to a specific subset of traffic and see how it performs.
And last, we observe the behavior of the new features that we've rolled out in prod pretty much every time. Once we've written code, we go and check it first instantly and then a little bit later to go double check how it's being adopted and how it's being used. Now, I've mentioned the idea of dog food a couple times. Our main prod cluster is reserved for user data. That's our prod cluster is how our observers, our customers are going to observe their own data. But we also have a dog food system. Dog food observes the behavior of prod. That's pretty great because when I roll out something new like the SLO feature, I can go look at the page views and go see how it's being adopted, go dive into some of those spikes and see what users are using it and what features they're finding most interesting, and can roll out and go to the users and find out what's happening. I can wrap other features around that to go detect whether there's errors happening. By the way, because dog food is an experimental system, it's got more feature flags on, there's also a somewhat higher chance that that'll fail. That's okay, we have Kibble. Kibble observes dog food.
It's turtles all the way down.
It's not turtles all the way down. We don't yet have something that observes Kibble. That data is in fact lost. And so that really is how we're able to get 12 engineers to deploy 12 times a day. So we heard earlier throughout the entire conference about the Accelerate research, about Dora's data. And what I want to tell you is that the Dora data is not just kind of 4 independent data points. The Dora data describes feedback loops, positive virtuous cycles that happen when you improve even one of those metrics. So let's start talking about lead time. The lead time at Honeycomb is, you maybe write a commit, and it builds and it says, oh, something's wrong. So you fix the test failures and you run the build again, and it succeeds. And then you get your peer to review it. That might take an hour. And then it finally gets built one more time when it gets merged into head. And then our push train runs once an hour. So that means that our lead time is at most, worst case, 3 hours to deploy a change. That works only because
our build process runs on every single branch, runs all the time, and takes reliably less than 10 minutes. And in fact, you can see the reason that we switched CI providers back in June. When our previous CI provider was no longer reliably providing 10-minute build times, we said, nope, this is getting too much in our way. We need to make a different business decision because we value productivity of our engineers and the lead time.
As a data geek, by the way, I absolutely love the fact they can look at this chart and like see how it was gradually growing as our test suites got more sophisticated.
And the provider got slower.
That's true too. And once the crisis moment happened, you can see that like the number keeps wiggling up, and once in a while you can see like in late October, there's the moment when the lead engineer said, something's too slow, I'm fixing this thing, and went in and did analysis, and everything jumped down again. By the way, one of the fun aspects of this rapid deployment change, last night I was doing a demo, and I noticed a small bug. I dropped it into the on-call inbox. The person who was on call said, oh yeah, sorry about that, I think that was a regression that we threw in earlier today. This morning I was able to redo that demo, and things were live and fixed. It's really fun to be able to get this quick turnaround.
So once you have a really great lead time, you can also increase the frequency of your deploys. So we don't want to ship things straight into production. There is some value to smoke testing. So we smoke test using kibble and dog food. So we literally have a cron job that runs once an hour on a specific minute past the hour on every machine in our fleet at a specific offset. And it will go ahead and start the update process to whatever is latest. So we have, at most, 1 or 2 new commits going out per build artifact, which means that if we cause a regression, we know pretty quickly what to roll back, and also we have a set of recent builds that we can roll back to. Similarly, our change fail rate goes down because we have such a high level of confidence in our code. The testing that happens on every single branch means that long before things even reach master, long before they become the latest build that gets pushed out, we already have a pretty good sense of how it's going to behave. And because we design for feature flags, it means that we can use flag flips or fix forwards rather than needing a special emergency rollback procedure. We had, I believe, less than 3 bad changes in over 2,500 changes last year. And finally, the time to restore goes down, right? Like, I can flip off a flag. It'll fix the problem in 30 seconds. If I can't do it that way, I can just push the second most recent build, which will take less than 10 minutes. And if I need to do a fix forward, that's literally just reverting the commit and then waiting for a new build to happen and then just pushing that out to all of our machines, right? It's not an onerous process to fix code in our workflow. So this is what high productivity project engineering looks like. Good lead time, leading to this virtuous cycle of having your deploy frequency be able to go up, having fewer changes fail because your tests are more likely to catch things, and being able to mitigate the impact of outages when they do happen. But what about infrastructure, right? This is all talking about changing the individual binaries that we run. How do we actually change the shape of which binaries we run? How do we scale up and scale down? Well, I have to remember that as an infrastructure engineer, my job is to empower the product to succeed. My job is not to pad my resume. My job is not to adopt Kubernetes for the sake of adopting Kubernetes. What we need to do is we need to build systems that are reliable and simple that product engineers like Danyel can use as a bedrock for building out product. So everyone starts somewhere, right? It was said earlier this morning, right? Like, we have to embrace the ugly. It is OK to start from an ugly place. What's important to do is to have some concrete steps that you can take to move forward. So that means that if there is a process that you're doing over and over that is not reliable because it's boring to the humans are not doing it consistently, we need to apply some automation there, focusing on doing that value stream mapping and identifying what's the highest return on investment. We also have to think about things that are maybe working OK, but are suboptimal. We have to fix that duct tape that's holding our systems together, and over time, replace it with more durable forms of infrastructure.
By the way, I should say this is even true of us. I mean, we've been showing this like very nice, beautifully automated world. When I first joined Honeycomb, a lot of it was held much more together with duct tape and cron jobs and hoping and praying. Liz showed up, looked around and said, oh my God, you people need an infra person. And started tearing through our code and, piece by piece, tearing off the duct tape and helping us solder pieces together to be more solid and more reliable.
Yeah, external perspective really does matter because it gives you the insight of someone who's not used to, oh, this is how we've done it before, or it's been behaving fine for the past 2 years, right? If I see a risk and I'm new to your system, I'm more likely to first understand, is that a real risk, and then try to fix it. The final bit that I think is really critical, especially to infrastructure engineering, is we have to have reproducible, clean environments, that we cannot have dangling pieces of production that are not checked in or differ from what's checked in, and that hygiene is an important part of running resilient infrastructure. So how did we apply this in practice at Honeycomb? First of all, we do not use Kubernetes in a load-bearing fashion. We do use Kubernetes for running kind of auxiliary helper jobs, but Honeycomb, the core product, runs on raw VMs. Why? It is much simpler. There is a lot less complexity, and I think that that really matters when you're such a small engineering team. So our VMs, if we have to kill a VM, a new VM gets spun up, it's cold booted using a chef script that configures it the way we expect it, and after that, we just run the chef script again every hour to keep it in sync. So we don't necessarily have to worry about establishing a container build infrastructure. We also, as Danyel was mentioning, we do have the cron jobs that run every hour that actually pull the requisite binaries that are latest, but out of Amazon S3. We love to use utilities in the cloud. We don't build our own generic blob storage, right? Things like Google Cloud Storage, Amazon S3, right? Those exist for a reason, so we make ample use of them so we can focus on what really adds value for us. And as I was mentioning, repeatable infrastructure with code matters, but you have to have someone gardening it. You have to have someone making sure that it's doing exactly what you expect. So the first thing that I wound up doing when I came to Honeycomb was I looked at it and said, wait a second. The way that people currently manage our infra is they clone the infrastructure repo, and then they use their own AWS credentials to diff the infrastructure, and then they send a pull request with the changes and copy-paste the diff in. And then when it's merged, they actually have to remember to go and type in the command to Terraform apply. It's like, wait a second, no, this is not going to work. This is subject to race conditions. Let's put this in one place so that we don't have to worry with people colliding with each other or worrying about what's the most current version of infra. This also means removing barriers to setup. Why is it that someone needs to clone the repo? Why is it someone has to download a copy of Terraform? Why can't they do it just in their browser? So it turns out that, yes, you can diff and release infrastructure changes from your browser just as easily as you might update documentation in a GitHub pull request on the web. So this is concretely what this looks like, right? Like you can literally go into our Terraform configs in GitHub, hit that little edit button, produce a pull request, and we'll get automatic diffs, and we'll get automatic test runs, dry runs of that, to make sure that it does exactly what we expect. And when it gets checked in, it gets automatically run. We automatically sync our head configs against our AWS environment. So this means that we always have an up-to-date copy of the infrastructure, and we no longer have to worry about infrastructure config diff. The other thing is that it's easy to accidentally apply a foot gun to your systems. And when that foot gun is accidentally tearing down your entire AWS environment, you probably don't want that floating around as a possibility. So we've chosen to adopt certain guardrails that make sure that there's always at least one copy of critical processes running on VMs inside of our infrastructure. And that if we have to do a resharding, that we don't accidentally reshard, that we're deliberate about resharding our storage systems. All of this enables us to, most of the time, let engineers and their peer reviewers, because this does go through peer review, go through with infrastructure changes without having to let the on-call know. And only if something is risky do we actually need to stop everyone and say, you know what, let's just watch this to make sure it works. This also enables us, because we're able to push infrastructure changes much more often, multiple times per day rather than once a week, once every other week, it means that we can do incremental changes, that we can really test the effects of changes to our infrastructure before they roll them out everywhere. But this relies upon having modern components, This relies upon being able to keep up with the latest providers for Terraform, for instance, with the latest Terraform language. And that if you feel that your continuous delivery of infrastructure as code is not up to task, then you're going to be afraid to change it, right? Having the confidence of being able to diff your infrastructure really enables you to make these kind of more sweeping upgrades to your config language. And yes, we have feature flags for our infrastructure. Let's talk through a couple examples of that. So first of all, we have the ability to choose to turn on or off AWS Spot on our auto-scaling groups. We have the option to say, you know what, under certain circumstances, stand up a special fleet, but otherwise leave that special fleet off. We have the ability to say, for this set of paths, route them to a special set of quarantine traffic processors that we've stood up for purpose so that we can run things like CPU profiling or memory profiling on them. And this also gives us a lot of confidence that we know if we're not using a module that we can safely delete it because the rest of our infrastructure continues to build and pass and get automatically deployed. Refactoring is a really, really important part of this, of really, really treating your infrastructure not just as I can stand up a static copy of things as they are now, but allowing you to really modify it and make it extensible for the future.
What a great story. Clearly, nothing ever goes wrong in this land of milk and honey over at Honeycomb. Why, we've never, wait. OK, fine, so we've had some failures.
That looks really bad.
That was really bad.
How bad was it? Should I be panicking? Should I, are we all losing our jobs?
So I'd like to tell you the story of July 9th, 2019, a story that honeycombers all know way too well. We had that drop there. We'll talk a little bit more about it, but I just want to zoom in so that you can watch what it is as an entire cluster, piece by piece, falls over.
Due to our own automation, of course.
Of course. And 10 minutes later, when somebody manages to find the change, revert it, and get us back up to speed, and life resumed as normal. But Liz started us off by asking this question of how broken is too broken? And to answer that, I'd like to take a brief digression into the world of service level objectives. Has that dogma started spreading around to this community? Everybody know what I'm talking about when I say that? A couple of yeses, a couple nos, some maybes. What we're looking to do is find a way to define the notion of success so that we can then decide what the notion of broken is, and then we can decide how much broken we're willing to tolerate, because nothing's going to ever be perfect. So SLOs become a common language that engineering and leadership and infra can share with each other to have a conversation really about what success means and what your code velocity can look like. The general idea is that if you can come to some agreement about reliability, if you can accept that nothing's ever going to be 100%, then at that point we're just negotiating how much failure you're allowed to have. And when you've had less failure than that, then you're doing great. You can blast ahead with exciting new code. And when you've had more failure than that, you should probably slow down and make sure to build up reliability before you move forward. This is not a conversation we have with customers. This is not a conversation that we try to write into contracts. This is a conversation, again, internally to give us a common language to talk about how bad is too bad. In a nutshell, we're just going to count events, and we're going to look at all the events that are eligible. That is to say, are interesting to our metric of what quality means. And then we're going to count the ones that are good and bad. So for example, a simple metric might be, has returned HTTP code 200 in less than 100 milliseconds. That is to say, the web page is doing the right thing. If it takes more than 100 milliseconds, it's not good. If it returns not at 200, that's also not good. So now we have a notion of goodness and badness, and that's great because now we can talk about what our availability is. It's just our good divided by eligible events. If you do that, and you pick a time window, then you have a bucket of events. And if you've got a percentage over that bucket, then you've got an error budget, which is just the amount of unavailability that you're allowed to have. So this is actually a factual statement of how bad things are allowed to get. You can use that to drive your alerting. Are we getting towards that amount of badness? Are we pretty far from that badness? Now, Honeycomb, in fact, has instituted internal SLOs so that we can discuss how much badness we're willing to tolerate. And we've picked a variety of them for different sorts of services. So for example, incoming telemetry, we want that to be rock solid, or as close to rock solid as we can get. We'll take 99.99% and call that good enough. We really want to make sure that incoming data gets stored. Our major interface for querying this data has a series of dashboards. Those should usually load in 1 second. We'll go with 99.9%. We're OK with sometimes things running a little slower. And we have a back-end query engine. Sometimes the questions people ask of that query engine are large and brutal, and we want to tolerate the idea that sometimes queries will take more than 10 seconds. So these are 3 very different levels of precision or of quality for 3 very different services, because we have different user expectations about what those might be. So with that structure in mind, let's go take a look again at this chart, this dramatic leap of 10 minutes. I'm going to put back on the title of the chart, which is user data throughput. So this is unfortunately our 4 nines metric, and that drop there, therefore, is a failure of us bringing in user data. By the way, if you're a company that does telemetry, that means that you're drawing wiggly lines for every single user. What users fundamentally come to you for is those wiggly lines. That gap showed on every single customer dashboard of every single view that they ever looked at until it aged out. That's as embarrassing as it can possibly get for us. We dropped customer data, as I said. When we do the numbers on that, and as I said earlier, we were able to get it back. Liz talked earlier about how we were able to do a 10-minute rollback, and we did that 10-minute rollback, and so we were back up to speed. Pretty much as soon as it went down, we glanced at, all the alarms that we had started going off, and we knew that it was bad. So we were able to roll back. We did the very first thing. We communicated to our customers, apologized for the outage.
And we told them about what was going on, right? Trust of customers is improved by transparency.
But we had an error budget. Now, if you calculate out what 99.99% of 1 month is, or what 1 minus 99.99% of a month is, you get 4 minutes. We allowed ourselves 4 minutes of downtime per month. This was triple that. So we'd burned triple our error budget, which was unfortunate. Now, according to our standards for what you do with an SLO failure like this, is you stop innovating. And we did. We halted deploys on the system, and we went into remediation mode to figure out what was wrong. So I'd actually like to talk a little bit about what we did in that context, what caused this to happen. At base, an engineer had checked in code that didn't build. Honeycomb now has 11 engineers, and we're accepting applications for new engineers, so I'd like your... We've all said the blameless postmortem thing, because after all, checking in code that didn't build shouldn't be a big deal. Because,
the CI is supposed to kick that back, right?
The CI kicked that back, except of course we were playing with our new experimental CI because it was self-wiring itself. And hey, it turned out that it was eating alerts. It was eating,
really important to check question mark, or $?
Yeah, that was bad. Of course, that's not a big deal because the deploy process certainly would never deploy an empty binary, would it? Well, our scripts did. Which, of course, is no big deal because, after all, when you put out that empty binary, the canaries should all yell, of course. We didn't have a health check or a rollback at the time.
So you can see that this is a sequence of 4 events, right? Like, this doesn't suddenly happen, right? Accidents happen from unanticipated consequences. But here's the good news. We're able to fix these things by prioritizing stability and not having this cavalcade of features that people were developing while we were frozen. We really prioritized stability. But we didn't do everything. We mitigated the key 4 risks, those key 4 risks that we talked about, and said, you know what? We don't necessarily need Kubernetes for this. We just need to check, is there a binary? Does it respond OK, or do I need to immediately roll back this release because my binary is not returning healthy? And after that, we were able to get back to building because we believed that even though we'd blown our error budget, we were confident that we were going to be able to achieve it going forward, at least until the next incident. So let's talk quickly about what's ahead for us. We continue to scale. We have many, many more customers than we did a year ago. So we need to continue making sure that our infrastructure and our product does the right thing by our customers. And that sometimes means launching new services. So we put out a blog post recently about how we launched a new service that makes use of infrastructure as code in order to make sure that we are able to catch up in event of delays in ingesting telemetry. We also spent less money. We are able to innovate with our infrastructure to use serverless to do most of our compute workload for queries instead of doing it on our rented servers. And that meant that we were able to achieve a significant cost savings. These things only would happen if we had sufficient confidence feature flagging, infrastructure as code, continuous delivery, to make sure that things behave the same before and after. And we're going to continue investing in infrastructure because that's really the bedrock on which we build the rest of our product. And we still maintain an on-call rotation where people get woken up during the middle of the night at most once per week, usually less. So, Honeycomb is not this ridiculously sophisticated company with billions of dollars. You can do this too. You just have to go step by step. You have to pick one service to start with to apply continuous delivery practices to, and really, really demonstrate that value, demonstrate that feedback loop, and then generalize it and spread it to your other services. We blog extensively about our experiences engineering with continuous delivery and observability, so please do check out honeycomb.io/blog. So this is how you really understand and control your production environments. You need to make sure that you have that drive to go faster. Make sure that you invest in having stable, controllable infrastructure. And don't shy away entirely from risks, but instead manage them and keep them under control. And finally, always be itching to improve. Always iterate on your services. Thank you very much.
Okay, so what's the blocker? What are the challenges in this area? Why can't we all do this? Who wants to start?
All right, so this is more of a question. One thing you mentioned is that you have an academic background, right? And as well as you said you'd made telemetry or instrumentation like a first-class citizen as part of it. Do you think your academic background necessarily influences you to do that more? Because for me, example, that's hey, we got to make money. And so I don't really care until afterwards. But do you think that helped influence you at all?
Yes, there's a lot of telemetry in there that people look at and go, oh, that's a Danyel question to ask. Absolutely.
Okay. Hi, I have a challenge. You mentioned that, well, even a small company can do it. It seems to me that it's easier for a small company to do it because I'm at a company that's not small and it's not gigantic, but we have 200 very entangled services that are running in production, and how do I just pick one of those services and make it work? And then, that's the dream, right? You pick one service, make it work, and everybody falls in line, but everything is so tangled together that it's pretty difficult. So how to deal with that?
I think one of the key elements there is defining your interfaces and APIs, right? If you are able to define that API on this one service, you can start to disentangle it, right? You can say, you know what, you consumer of this API, we promise to keep the API stable. We're going to make changes to it on the back end that improve the performance or improve the reliability, but you don't have to care. You can keep on calling that binary, right? So I think that if you're having problems disentangling things into smaller pieces in order to be able to do this, then, yes, don't start with doing the CI and moving fast bit, right? Start with doing the API design, the team API design in order to make sure that it works.
I'm going to abuse my privilege and ask Steve to kick in. How do you tell people that know where to start?
Well, yeah, if anybody has missed me rambling over the past couple of days, I think, the visibility piece and knowing what you have is key to not only picking a direction, but starting the conversation, right? And getting everybody aligned on the fact that this is something that needs attention and getting the ball rolling so that you can start to define the edges of what is a manageable bite to take off and chew on to demonstrate some wins and start things moving.
I love doing that to people. I apologize.
So actually, I'll take inspiration from abusing the mic and say, also remember that this presentation is the backward half. It's the story of success of how they turn things around. So was things starting, did they look this clear? Was the series of steps, oh, we have to do A, B, C, D? Probably not. For my own sale and for my own stories, it serves as a wonderful narrative. I love telling those stories, but often it's just a whole pile of mess, and it's like, well, let's start tugging on this string, let's start tugging on this string, let's start tugging on this string, and see which ones actually have the most looseness in the knot to actually keep on pulling and move on from there.
Yeah, I would 100% agree with that, and I think that's why, for instance, we didn't jump right to Kubernetes, right? That would be kind of the obvious thing people would tell us to do, but that's not where we saw the value, right? Like where we saw the value was, let's make sure that every commit, or that every release contains about one commit in it, right? Like that was our starting place of trying to break the changes down into incrementable, releasable units, and then figure out how do we deploy them to production, and then figure out how do we actually observe how they're behaving, right? Like there's kind of this cycle to how the software development life cycle that is not necessarily solved by adopt this one technology, right? It's all driven by problems you're trying to solve.
And I just add, it's really important to realize this is really experimental. A lot of the strings you pull turn out not to have any give to them. And the number of exciting infra projects that somebody has spun up at Honeycomb and after 2 weeks is like, so that didn't work, is actually also really high.
Yeah, speaking of, for instance, running Kafka, outsourcing Kafka, that was brought up in a talk this afternoon, right? Like, I wound up spending a bunch of time figuring out what's the right decision. Should we outsource Kafka right now? Are there optimizations we can make to our Kafka? I actually ran this experiment that took me easily 2 months to figure out, can you run Kafka with a hard disk backing the cold storage and an SSD backing the warm storage? And it turned out to not work, right? Like it was in some aspects a waste of 2 months, except for we learned a lot of things. And we also learned that it was the right thing for us to keep running Kafka in-house at the moment, right? Like those are the kinds of things that you get through experimentation, is sometimes the losses are just as important as the wins, yeah.
Which actually is a great segue to the successes thing, believe it or not. Because I really liked what we were talking about reaching out to the customers when there was an issue. My better half is a Lego fanatic. I got her one of the huge Harry Potter things for Christmas, and it was missing parts. And I was furious, but their reaction, their fix was phenomenal. And she's even more of a Lego fanatic. So what did your discussion with the customers look like? When you notified them that you had the issue, or I guess they knew because they also had the dip, but when you talked to them through that, what did that look like? What was that conversation like?
We have a customer in the room who I'd love if they could reflect on it. But otherwise, in the end, for a lot of our customers, 8 minutes wasn't actually the biggest thing for them. So it was embarrassing, but not frustrating.
Yeah, I think to add on to that, right, our customers didn't want to know, oh my goodness, we're so mad about 8 minutes, right? Our customers wanted to know, is that going to happen again, right? Like, do we have confidence that you're not going to lose 8 minutes during Black Friday? Do we have confidence that you're not going to lose 8 minutes, a day from now, a week from now, a month from now, right? So that's why we paused making changes to our features for the essentially week and a half that it took us to really mitigate each of the things that led up to it. So that, right, like I think that's the more important part about customer confidence is communication so that people feel like they understand what happened and why it's not going to happen again, rather than just the generic, we regret that this happened, it's never going to happen again, we're not going to tell you why, right?
Yeah, I think that's the big success there is the transparency gave them the confidence, right? They didn't think you were going to hide something from them and so forth. Anybody else have successes they want to talk about? Things that they did that made them get on this path a little better? No, we're all tired. It's late in the second day. So this is, to me now, is actually an interesting question because I had no idea, and I was surprised that you're running on VMs, and I think that's really cool that you didn't do a thing because it was shiny. What do you want in 2 to 5 years to enable this? Apparently you don't need anything new. But now let's say someone, I know you're not greenfield, but you're not 10, 20 years legacy either. What are the things that could help people that don't have that fresh start? I know we've kind of turned this into a Q&A a little bit, but what about people that don't have that fresh start? What can they do to get things going?
I think this is one of the real challenges that Kubernetes has, right? Like it's demonstrating the incremental value over skipping straight to serverless, or the incremental value of, you know what, just use plain old VMs, right? Like, I think that it's a matter of how quickly do you want to deploy to production, right? And I think that kind of unifying those various models of the world is the thing that would really simplify infrastructure decisions for people. So that they wouldn't necessarily need to worry about where is this going to run. If you just specified, these are the parameters that I expect, right? I expect to be able to update my binaries, you know, roughly once a week or once a month or once a day, right? And I expect them to be down for at most 5 minutes when they update, right? Like, that these are constraints that are not specific to the underlying technology, right? Like, that platform providers from a compute perspective should provide that as a primitive. So I think this is why we see things, for instance, in GCP land where they're unifying the world of, you know what, serverless, managed VMs, managed Kubernetes, right? And just saying, you know what, give us units of compute to run, we'll run them for you, right? And I think that's really where that would really simplify our decision making about what runs where.
Do you have anything to add to that?
Not specifically to that, but I guess thinking about, I'm thinking a bit back to the question of, like, in a big organization, how do you start and how do you go about this? And I think to me, and some of the lessons from what we've been hearing, is it's around, like, picking off obviously a small piece to start with, but I think it's all, and taking that piece and trying to experiment with, you know, how to do these things. For that piece, how can I make sure that we can deliver, you know, quickly and reliably, you know, the 4 metrics or whatever it is, it's going to, you know, that you need to focus on. And it's also realizing this experiment, because I think one of the things that people fall into is thinking, oh God, we've got to pick the right technology, even for this small thing, like we, you know, which, you know, we're going to do Kubernetes and which vendor and all that. And it's like, yeah, don't worry about it. Pick something that you're going to learn from and accept that, like, you're going to end up doing something different later on.
So I kind of want to, I think this is boiling down a lot of the themes that we're hearing this week, or this past couple days, that it feels like a week, yeah. I think we're seeing a lot of, you have to communicate and you have to talk about how you're all going to get there together. I keep hearing that just constantly throughout every single talk. Everybody ends with, you can do this, start small, communicate where you're going, and all move forward together. So I think with even having talked about brownfield deployment, things like that, even just starting out with, let's get in one room and start talking about how we can get there, and saying, okay, we have the value mapping, we have all of this data, what can we improve on, but getting everybody's perspective on that. And I guess that kind of boils down to what continuous delivery is all about.
Yep. Anybody else? He wanted to applaud that one.
Well, actually, separate comment as well, and I'll give it to Abby in a moment. But answering the question of what do you want to see in 2 to 5 years, I'm not even sure I want to wait 2 to 5 years for this. Liz, if you want to give a presentation on why Kafka doesn't work in your infrastructure, I want to see that. And actually, I'll open it up to conference organizers as well, because we have one standing right up here. Let's highlight more failures, and let's make sure we invite more bad stories, because again, I mean, there's plenty of stuff to learn. I'm thinking also of the science recreation crisis of everyone only publishes their good stuff. So are we seeing significant results? Well, let's talk about our failures more.
I was just going to call out, we talk about starting small and getting somewhere, but we just had a really big success of moving to continuous delivery in my organization, and actually it was about breaking people's illusions of what we are currently doing. And I think that's a phrase that comes from the testing world, is that we don't break your software, we break your illusions of the software. And it was very much like our entire slide deck that went out to tech leadership and product leadership and everything had a whole bunch of explanations of how what we were doing was unsafe. And going to continuous delivery was going to make some of those things safer, some of those things no safer, but a lot more obvious that they weren't safe, but they weren't any less safe. And so I think that's the conversation, is just making sure people can actually see what's going on, because it can shock them into moving forward as well.
So speaking of failures and conference organizing, and this is a last discussion. No, so no, actually not going there, but thank you. So one of the things that was brought up to me that we didn't do is we didn't talk about when continuous delivery fails us, and I'm sure it does fail us sometimes. And like, this conference is wrapping up, but maybe that's an idea for the next one. So I just wanted to share that.
Thank you very much again for the talk. Thank you for your participation.